Hey guys! People have been asking me to create a proper tutorial on how to build the machines I showed you in the previous videos, so I decided to have a build with me kind of video. Just fire up MockMechanics and follow along. I do something, you should pause and do it yourself. That's the best way to learn and not forget, by example. I'll try to be thorough, but if I miss something, just ask me in the comments. I will answer every question. There is also the documentation on the site on the Docs tab. It's short and comprehensive, so you can also have a look there. So here's the plan. I'll explain the basics while building a few very simple things, doors that open and close, turning lamps on and off, and so on. Then we'll start building more exciting stuff. And I'll finish by showing you exactly how I built the piano, the clock, and the safe from the first video. But you don't have to watch that one. I'll explain everything here. But before we start, let me show you what I've been working on lately. I implemented gear mode that I promised in my first video, except it's not a mode because I found a way that's much more elegant. You just have a gear part here on add mode and you add it in stages. Click on a track, click on another, then add a multiplication factor. There. Now every rotation of the first track you clicked is multiplied in the second. Since I entered a factor of 2, the second track rotates twice for every rotation of the first. And since the gears are regular parts, we get a lot of stuff for free. I can change their colors, move them to a new location, and hide them in a different layer. And there's more. I also can add gears between a track and a wagon and get this linear gear thing, I forget the name. Neat, isn't it? It's already available in the latest version for download. And you need to get that version if you want to follow this tutorial. Also, just a note about shortcuts. If you don't want shortcut hints to appear, just change the settings file accordingly and restart MockMechanics. Okay, let's begin. So you just open MockMechanics. What do you see? The ground grid. You can rotate by dragging the right mouse button and pan by dragging the middle mouse button. You can also zoom with the wheel. So let's add some objects. For that you use add mode, here on the right. On this mode, you can select one of these objects at the bottom and add it to the ground. Try adding a block or a button to the ground. You can also add objects to the surface of others. Add a track to this block and another one to the side. Now add a track to the end of this track. Just click on the face of the helper cube to select the direction you want to add it in. You can also drag the object you just added before you release the mouse button. Objects are added in a grid, even when added to another object. You can press Shift while dragging to make the grid spacing smaller. A wagon can be added only to paths created by tracks, so click anywhere on this red path to add a wagon to it. Why is it called a wagon? Because it can move on this track path. Go to simulation mode and drag it around with the left mouse button. Simulation mode is where you interact with your machines. And you can add things to the wagon as well. There are a couple of different shapes here. Try adding a cylinder, a cone, a sphere, also a lamp, a speaker. You can't add something to a curved surface right now, only to flat surfaces. Now let's modify the objects. Go to Edit mode and click on Move. You can move an object on the surface it's on and press Shift to change the spacing of the grid again. In fact, you can use Shift with most of these submodes to tweak their behavior. When added, objects sit on the surface you place them. You can change the distance to that surface with this Change Height submode. Rotate with this. Scale with this. Not everything can be scaled. You can copy an object with all its children with this. Just click on an object while pressing Ctrl to select it. It will flash yellow. Then click somewhere else to add it there. And you can drag it just like on add mode. You can also transfer objects with all their children to a new surface. For instance, let's move the track path to the ground. Just like copy, Ctrl-click the object, then click somewhere else to transfer it there. I didn't explain this before, but when you add an object to the surface of another, that becomes its parent. So the parent of this block is the ground. These track's parent is the block. The wagon's parent is the track you added it to. This button's parent was the ground, but now it's the block, see? Change the color of objects with the color mode. Click on a color, then click on an object. Layer mode is used for organizing objects and for hiding things. Drag an object to a layer square to move it there. You can click on a layer to view it, or shift-click to add it or remove it from the visible ones. You can also shift-drag something to a layer to move it and all its children there. And I forgot to tell you, you can right-click on an object to set the pivot of rotation there. The camera rotates around it now. Or you can right-click on a point in the ground. Okay, let's start moving things. Press New to reset the game and build a path like this. Scale the second track to be 2 units long. Look at the feedback here at the bottom of the screen. Then add a wagon to it. Now in simulation mode, you can drag it. You've seen this. Now let's go to property mode and click on the wagon. You see this value? It's the distance from the starting of the path. Drag and you see. Right here the value is 1 because this track is 1 unit long by default. And here at the end it's 3 because we scaled this track to be 2 units, so 1 plus 2 equals 3. You can control this value with a graph using a graph chip. Let's add one in add mode. Go to graph mode and click on the chip. Now you're seeing the inside of it. Click on the wagon to add it to the chip. A function appears that goes from 0, 0 to 1, 1. It's a function of time versus value. It's saying that at time 0 the value should be 0, and as time goes from left to right, the value mirrors it, so at time 1, that is 1 second, the value should be 1. Run the graph by pressing this button or the shortcut R. See? The wagon goes from value 0 to value 1 in 1 second. Remember, the value of the wagon is the distance from the start of the path. Let's make it go to the end of the path in 1 second. Zoom out of the graph with the mouse wheel and drag it with the middle mouse button, which is the wheel in my mouse. Now at time 1 we want the wagon to have value 3. Just drag this node to the value tree. Press Shift to snap while you're dragging. The info at the bottom shows the exact value of the node. Run the graph again. In 1 second it goes from 0 to 3. It's going too fast. Suppose we wanted to go to the end of the track, but at the same speed as before, which was 1 unit per second. Just move the node to the 3-second mark and run it again. Now let's move it to the end and then back to the beginning. First add a new node, press Add, then click on the function. Drag the node here, don't worry, the function reorganizes itself so that nodes are in order. Now if we place a node at time 6 and value 0, and run the graph, it will go to the end and then back. These buttons control what you can do with nodes. By default you can move them. Or set the X value precisely. Click on a node when this white band shows, then the bottom becomes white when it's expecting you to enter some text. Enter 1 and press Enter. Same with Y. You've seen Add. You can also delete a node. You can press View to reset the view of the graph, and Lengths to show the lengths of each leg of the wagon path and the total. Just click on the function. See? 1, 2 and the total is 3. Toggle I'll explain later. You can click on the part again to remove it from the graph, and you can have more than one part on the same graph. Let's create another track here and add another 2 wagons and change their colors. Let's move this out of the way. Oops. When you make a mistake with the shortcuts and get stuck with some blue text, just press ESC. It'll make sense later why shortcuts behave like this. Now back to graph mode. Add each wagon to the graph. They're all here now. If you press run, you can see it. Let's change their timing. You can also have the same wagon on a different graph. Let's add another graph chip. On graph mode, click on the new chip to select it. Clicking on chips selects them. On other parts, you add or remove them from the current selected chip. Let's add the green wagon to the new chip and let's make it go the other way, from 1 to 0. Let me remove these other wagons. Up and down, up and down. There is also a different kind of motion, rotation, and it's created with a track. Add a track like this and add a block to the top. Or click anywhere, it's the same as adding to the top. Now scale the block into a blade. On graph mode, add the track to the graph. The value of the track is its angle from 0 to 1, 1 being 360 degrees. If you want it to rotate twice in 1 second, make it move from 0 to 2, or 720 degrees. If you wanted it to move halfway, wait for a second, then move back, you would do this. This graph is too thin, it's hard to see. Change the aspect ratio by zooming with the shift pressed, then zooming back. Now you can see this track goes from value 0 to 0.5. Stays there for a second, then goes from 0.5 back to 0. That's all there is to moving things in MockMechanics. The only missing thing is the toggle button, which I'll explain later when we need it. Go ahead and save your work with Ctrl S. The button turns white for you to enter a name, like tracks. Next time you save, you don't have to enter a name, and it saves a new version. Then you can open it by just entering the name. Okay, so now you know how to add objects and scale and move them to create whatever structure you want. You also know how to add them to a graph chip to make them move in any way you like. But how do you program the machines? For instance, how could you rotate that blade we made with the press of a button? First, let's light a lamp with a button. Add a button, a lamp, and a motherboard part. Let's make the lamp yellow. On motherboard mode, click on the motherboard to select it and click on the button and the lamp to add them. Now on property mode, you can see that if you set the value of the lamp to 1, it's on, and if you set it to 0, it's off. And the button is 1 when pressed and 0 when not pressed. What we want is to set the value of the lamp to be the same as the button. 1 button pressed and lamp on, and 0 button unpressed and lamp off. You can connect the values of the button and the lamp by using this connect button. Click on the button pin, then click on the lamp pin. A connection from input to output is created, meaning the value of the lamp will be set to the same value as the button. Now, if you go on simulation mode, pressing the button lights the lamp. You can also run a chip by setting its value to 1. Let's add that chip to the motherboard. And connect the button to the chip. Now pressing the button also runs the chip. You know enough now that we can start building some more interesting things. Let's build a door that opens or closes with the push of a button. Add a block here and then add a track for that door to run on. Add a wagon to the track and add a chip. Now add the wagon to the chip in graph mode to make the wagon move from 1 to 0. Run the graph to test it. Let's add a block to the wagon to be the actual door. and another block here to serve as the door frame. Now add a button and a motherboard. Add the button and the chip to the motherboard and connect them. Pressing the button opens the door. Let's add another chip to close it instead. Just make the value of the wagon go from 0 to 1. Now add the other chip to the motherboard, delete this connection and create a new one. Now the button closes the door. Finally, let's add this probe part here, and another here. The probe has value 1 when it's touching another probe and 0 otherwise, see? With the door closed, the probe value is 1. When opened, the value is 0. Let's add the probe, either is fine, to the motherboard. Now let's delete this connection. This chip opens the door, click Run and click on the pin to test, and this one closes the door. What we want is the open chip to run if the button is pressed and the probe is 1, and the closed chip to run if the button is pressed and the probe is 0. We can do that by using a few logical gates. A NOT gate turns a 1 into a 0 and vice versa. We could have inverted the connection between the button and the lamp by using a NOT gate. When I press the button, its value is 1, which means the output of the NOT gate is 0 and the lamp is turned off. When I release it, the button is 0 and the lamp becomes 1. If I use an AND gate here, the value of the chip is 1 if the button is 1 and the probe is 1. So with the door closed, it opens the door. With the door opened, it does nothing because the probe would be 0 and the AND gate output would be 0. Setting a chip value to 0 does nothing. On the second tab though, I use a NOT gate to flip the value of the probe and use another AND gate to connect the button and the probe to the other chip. Now when the door is open, the probe value is 0, which means the output of this gate is 1. So when the button is pressed, both inputs to this and the AND gate are 1, and so the output is 1 and the closed chip is run. Now the button opens or closes the door. Let's make something different. You don't like the button that comes with MockMechanics? Let's make a new one. Let's add a base here and a track for the button to move on. Add a wagon and a cylinder to it. Let's make the track just 0.2 units long. Add a graph to move the button down, and the graph should move from 0.2 to 0 then. Run the graph to test. Let's create the chip to move the button up and test it. Now the movement is done. Move down, move up. Let's add a motherboard to be able to run these behaviors. The basic shapes, the block, the cylinder, the cone and the sphere all behave like the button with regards to the value. Press it and the value is 1. Release it and the value is 0. So if we add the cylinder to the motherboard and connect it to the down chip, pressing the cylinder should run the chip. Except it didn't work. Toggle the cylinder pin as a trigger. I will explain in a minute. Now, pressing the cylinder moves it down by running the down chip. Creating a connection with the NOT gate moves the button up when you release it. The button's done. Let's just make it a little prettier by adding a cover and hiding some things in a different layer. Now we can use it. Add a motherboard and a lamp as before and connect the button to the lamp. Remember to set the button as a trigger and voila! The new button works. What's this trigger business? A motherboard is run when one of its inputs change. But how does it know which pins are inputs? In the door, for instance, we use the probe as an input in the sense that we read its value instead of setting it. But we don't want to trigger the motherboard when the value of the probe changes. We want to respond to the button press only. That's why the button is set as a trigger. Buttons are triggers by default, but you can toggle any part as a trigger or not. I think that explains all the commands from the motherboard. The OR gate is 1 when any of its inputs is 1. The only missing one is the script, but I'll leave that for the next tutorial since it's an advanced topic and not needed often. Let's make a piano instead. Start by placing a block here to serve as a base for a key. Scale it up. What we want is another block to be a key and it should move on a horizontal hinge. Like this, but it should be placed in front of the base. We can add a little block here and move the track there. Let's make the track smaller. Now let's create the up and down behavior of the key. Add a graph and make the track move. It's moving too much, let's adjust the final value. There you go. Now add another chip for the up motion. Start with the same value of the other chip, then go down to 0. Run this chip and the key is pressed. Run this other one and it's released. Let's swap those two chips to make it easier to remember which does what. Now create a motherboard to connect clicks on the key to its behavior. Add the key, make it a trigger and add the two chips. When the key is pressed, its value becomes 1 and we want the down chip to run, like this. When the key is released, its value becomes 0 and we want the up chip to run. There, you can now press the key. But it does not make a sound. Let's add a speaker part here and add it to the motherboard. When the key is pressed, we want the speaker to play its tone, which it does when its value is set to 1. One key is working. Let's duplicate the key and change one of the copies into a black key. Go to Edit mode, Ctrl click on the base and normal click here to add a copy. Make this key thinner, shorter and then turn it black. Now all keys work, but they make the same sound. Go to Property mode, click on the speaker and change its frequency. You can create the rest of the piano yourself. One final note about the piano. How did I create the automatic player from my last video? Simple. Create a block moving on a track like this. And add a probe to it. Now add another probe here and add it as a pin to a new motherboard. The key should be set to the same value of the probe, so just connect them and make the probe a trigger. There, Now when you move the block up and down, the key plays. This tutorial is running a little long, so I think I'll split it into two. On the next one, I'll explain how to use the script command from the motherboard, what the toggle command in graph mode is for, and we'll build a few more complex things like the safe and the clock, including this part that works like a while loop. We'll also use the physics engine to move balls around like in the mixer. And I'll show you how to use the library parts that I built so you can reuse in your own machines like the lever, this copier, and so on. Again, if anything was unclear, ask in the comments and I'll do my best to explain. Thanks for watching and see you guys on the next one.